The paper of the day is the design and implementation of a log structured file system. This paper presents a new technique for disk storage management called a log structured file system. A log structured file system writes all modifications to disk sequentially in a log-like structure, thereby speeding up both file writing and crash recovery. The log is the only structure on disk. It contains indexing information so that files can be read back from the log efficiently. In order to maintain large free areas on disk for fast writing, they divide the log into segments and use a segment cleaner to compress the live information from heavily fragmented segments. They present a series of simulations that demonstrate the efficiency of a simple cleaning policy based on cost and benefit. Authors have implemented a prototype log structured file system called Sprite LFS. It outperforms the current Unix file system by an order of magnitude for small file writes while matching or exceeding Unix performance for reads and large writes. Even when the overhead of cleaning is included, Sprite LFS can use 70% of the disk bandwidth for writing, whereas Unix file systems typically can only use 5 to 10%. Evaluation. Throughout this paper, their policies implemented are reasoned out by simulations. The segment utilization factor for cleaning segments are simulated, and a cost-benefit policy was used to differentiate the locality behavior accounted for cleaning thresholds. Sprite LFS, a prototype, is evaluated and compared to Sun OS file system for small files, read, writes, macro benchmarks. An LFS has 10 times speedup for creating and deleting files and has slightly better speedup for reading. In case of large files, Sprite LFS has comparable performance and even better in some cases. Overall, LFS seems to have better disk utilization bandwidth of 70 to 75% compared to Unix file systems 10 to 15% utilization. A lot of empirical data on disk utilization and cleaning overhead is also mentioned. Contribution. Paper constructed a prototype log structure file system called Sprite LFS, which is now in production, used as part of the Sprite network operating system. Benchmark programs demonstrate that the raw writing speed of Sprite LFS is more than an order of magnitude greater than that of Unix for small files, as those including reads and large file access. Sprite LFS is at least as fast as Unix in all cases but one, that is, files read sequentially after being written randomly. Paper also measured the long-term overhead for cleaning in the production system. Overall, Sprite LFS permits about 65 to 75% of a disk's raw bandwidth to be used for writing new data. The rest is used for cleaning. For comparison, Unix systems can only utilize 5 to 10% of disk raw bandwidth for writing new data. The rest of the time is spent seeking.